draw a force diagram. So we'll get our axis drawn here, and we'll do that in yellow. So there's our axis, and now we're going to put our forces on it. Our forces we will again do in green. So we have a force going this way, we have a force going up, and we have a force going down. And we need to label those. And it's pretty easy. We have a frictional force going off to the left. Oops, right, excuse me. A W and an N. So if we look at our forces, we see that the accelerated force will be a friction, but in this case the acceleration is in a circle, so that friction has to equal the centripetal force. Now we can make a few substitutions. Centripetal force we learned is mv squared over r, and frictional force is mu n, which will be mg. Now before we can start using our equations, we've got to do a few conversions here. It tells us that we're going to be traveling at 3,600 RPM. So that's 3,600 revolutions per minute. We need to change that to meters per second or centimeters per second. So if we do it to meters per second, we know that one revolution is 2 times pi times 0.11. That's 11 centimeters in a meter. And then this, we change 1 minute to 60 seconds. And if we do that calculation, we get 41.415 meters per second. And that's the number we're going to use in our equation. So back to our equations here. We have an m on both sides, so we'll divide those out before we start. 0.415 squared divided by the radius, which will be 0.11, 11 centimeters in meters, equals mu times 9.8. And we solve that for mu. And our equation, our answer comes out to be mu equals 0.16. There is no unit, and that is our answer.